So let's take a look at how we can actually complete example number 1 using Chevyshev's theorem. Let's see what this question asks. The salaries of State U faculty members follows a strongly skewed right distribution. Okay, immediately I should note then, empirical rule is not in play, but Chevyshev's theorem can be used because it works in any distribution shape. Okay, good. Now this distribution of salaries has a mean of 87,000, standard deviation of 28,000. Okay, part A. Can we use the empirical rule? Well, again, we already answered that. No. The distribution is not bell-shaped. Okay, so that's pretty easy. Now, I do know that it happens to be a skewed right distribution, which means that if I was to kind of sketch it out, my distribution would look something kind of like this, where it's like a lot of data on one side and it tails off on the right. So this might be something more like the shape of my distribution. But now remember what this means. If there are a lot of high values in the data set, remember that that means that my average is going to kind of get pulled up by those high values, whereas my median value will probably stay a bit more fixed towards the center. So, if we measured the median salary of faculty, would you expect it to be the same as the 87,000 average, less than, or greater than that $87,000 mean value? Well, again, since I have a skewed right distribution, I know the mean gets pulled up into that tail, so I would say that we would expect the median to be lower than the mean, since the large values in the data set, and I'll put here which make it skewed, will, I guess I'll put this in quotes, it will drag the average up. We talked about that actually a couple sections ago as well, I think back in 2.2. Okay, well we still haven't gotten to any question yet where we've been required to use Chevyshev's theorem, but part C I think will definitely ask this. Notice at least what percentage of faculty earn between these different dollar amounts, 52,000 and 122,000. Okay, well to figure this out, again I can see that maybe I should start to go ahead and draw out a little bit of a picture. So I'm going to draw a little number line here. Remember that my number line is meant to stand for or count here different salaries, right? That's what's going to go on my number line. And I know that I have a skewed right distribution that maybe sits up above it. So if I want, I could draw something that maybe kind of looks like this, skewed right. Now, I know that my average value is maybe going to, let's say, be somewhere over here. We said that this is 87,000. And then my standard deviation is going to be 28,000. Okay, well what I want to do is to figure out, if I'm going to use Chevyshev's rule here, I need to kind of figure out, again, how many jumps away from average these numbers happen to be. How many jumps? Are they 2 jumps, 1 jump, 6 jumps, 10.5 jumps? How many jumps away are they? So I'm going to start by just making individual jumps to see kind of where we land. Notice every jump is worth 28,000. So if I take 87,000 and I add on 28,000, I can quickly see that's going to be what, like 115,000. Okay, so I haven't hit 122 yet. Well, let's go ahead. We'll make another jump up here. And if I make another jump, I will land at, let's see, adding another 28,000 to this would bring me to where? Well, let's see, if I need to, I pull up a calculator, right? I have 115,000 and I'm adding on another 27,000. So that would bring me up to like 142,000. Okay, so 142,000. Now, I know that this value in here of 122, I guess that's going to be right here. So notice that how many jumps away is it? Well, it's like one jump and a little bit more. Not two jumps, maybe like 1 point something number of jumps. Okay, well, let's go backwards to find where 52,000 would be. Let's start making some jumps backwards. If I go down by 28,000, oh, whoops, did I do 27,000 before? Yep, I did 27. That was supposed to be 28. So this number here should be 143,000. But if I go down by 28,000, let's see what we end up with. That'd be 87,000 minus 28,000. That should bring me to 59,000. Okay, well, I'm not quite low enough then, because I need to go all the way down to 52,000. Again, I can make another jump. And I can say that if I go down another 28, that would bring me to, I think, 31,000 is where I would be. 31,000. Okay, so I can see all these different markers along here. And I can now place 52,000. I don't know, it'd be like somewhere over here. Again, it's one jump and a little bit more away from average. So I'm going to go ahead here and just try to write in each of my values. There's my 52,000. And here's my 122,000 at each of those green markers. I need to figure out what percentage of the data falls between here. Chevyshev's rule requires that I figure out how many jumps away from average this actually is. I need to find z. However, finding z isn't actually that tough. So I'll state here that we need to find z. So I can say that we calculate that z would be equal to, let's see, I know it's supposed to be 1 point something, but I need to figure out like how many 28,000s do I have to move over in order to get to this green line. Well, there's a really easy way to do that. The first thing that I'm going to do is I'm going to just try to measure this distance in here. How far is it from 122,000 back to the middle? Or how far is it from 52,000 back to the middle? Well, I can do both those with a simple subtraction, and let's see what we come up with. Notice if I took 122,000 and I subtracted off my 87,000, I can see that there's a gap of 35,000. Notice I get the exact same thing if I actually just do a measurement on this gap from 87,000 down to 52,000, right? So what we see is that actually both these numbers are equally distant away from my center value. Now, if both of them are 35,000 away, that's the number that we got here, I want to figure out how many times does a 28,000 go into that value. So notice that really what I'm setting up here is the following. I'm doing a calculation like taking my 115,000, subtracting off my average, so I can find that distance. And then once I have that, I'm going to divide by my 28,000. And if I do this, I should be able to figure out how many jumps away my green numbers are. Okay, so I'm going to go ahead and do this here. I know my top is going to be by 35,000, and so I just really want to divide by that 28,000. So notice that gets me 1.25. Okay, so I'm going to write that down, 1.25. So how many blue jumps do I have to make to land at this green thing? One jump and then a quarter of a jump. How much if I go down? Same thing. In fact, if I was to ever ask this question with Chevyshev's rule, I always have to give you green numbers that are the same distance away from the center. Now, once I have z, I can then go ahead and actually use Chevyshev's formula. So I'll say here that by Chevyshev's theorem, we see that 1 minus 1 over z squared is going to be the same as 1 minus 1 over 1.25 squared. Now I'm going to go to the calculator to enter this to see what we come up with. So let me clear out all of this. This is going to be 1 minus 1 divided by 1.25 squared. Okay, so let's see what we get. I get 0.36. So I can see here that this comes out to be 0.36, or 36%. So we can then claim that at least 36% of faculty earn between $52,000 and $122,000. We got it. Notice that the process of using Chebyshev's theorem is a bit more complicated because we have to first find our value of z, then figure out how to actually plug that into the formula, and then third, we're able to write that as a nice conclusion. Hopefully this gives you a sense of how we can use Chebyshev's theorem to answer some questions. In the next video, we'll take a look at example 2 to see how we can answer some similar questions, but also change things up a tiny bit.